We will be discussing the sixth module of the data warehousing course. The sixth module is about online analytical processing, widely referred as OLAP. So now we will look at the basic concepts of OLAP and how does it compare with the other information access and analysis methods. So first let us look at the characteristics of strategic information. As we all know, the data warehouses are mainly used by the decision makers and the knowledge workers. They are not interested in the operational information, but rather they would take strategic decisions based on the multidimensional information of the organization. And when they want to make a strategic decisions, as we know, there is a huge amount of risk. For example, if we take an automobile manufacturer, a strategic decision may be going for a launch of a new product or strengthening the sales team in a particular region or shifting the some of the operations from one place to another place. And such decisions involve a huge amount of risk, considering that the organizational resources, huge amount of organizational resources, either the material or men, have to be engaged in those strategic activities. So what they need is a good information which is reliable and presented in a way that enables them to make the decisions. So here we have some list of characteristics that apply for the strategic informations as required by the organizations for the decision making. So it should provide an enterprise-wide view. In fact, a departmental view may not be adequate for a strategic information decision making. As we know, the decision makers are generally placed at very top of the organization, and they can take decisions along several dimensions. For example, to improve sales, they may make changes about the product, or they may make changes about the people, or they may increase the pricing aspects. So either the price reduction or some other form of promotion. Or they may think in terms of redeploying the people, thinking that if they think that the sales people are unable to do the delivery, so some strengthening has to happen. So as you can see, each of these is representing a different dimension along which they can act. So what they need really is not a departmental view just indicating the assets or a particular product descriptions, but rather they would require an enterprise view that incorporates the multidimensional aspects that are required. And the information must be accurate, because any error in a strategic decision can be far more expensive than an error in the operational matters. And considering that the information is meant for decision makers and not for technical people, it should be easily accessible and should be intuitive. And considering that they use the information in very unpredictable or ad hoc ways, the information should be provided in such a way that they can create their own access models in simple ways. And the information provided should be representing one version of truth. It is possible that the values used in one department can be different from the values used in another department for similar fields. For example, a gender can be represented as 1 or 2 in one department table, and in another department table it can be 0 or 1 or Y or N or F or M or anything. But when you are integrating the entire information, or similarly if we are looking at the sales amount, so in one database we may be representing the sales amount with the tax, and in another database we may be requiring to show only the amount which is inclusive of the tax, or with some of the other elements included. So in that sense, whatever information that is provided for strategic decision making should have a one version of the truth. So that is, we need to have a very clear-cut definition and should be as per that. And it should be timely. That is, the decisions will be more effective if they are taken in a timely manner. So now we are going to study online analytical processing, which is used to help the decision makers. So let's look at the definition for the online analytical processing. It is something meant for executives, managers, analysts, and should provide a fast and consistent access and enable the interactive mode access. So that is to say, as they're looking at, let's say, the sales data of a particular region or on a particular product, they may become curious and say that, why not I look at the information on another region and another product, and that may give me a better perspective. So the OLAP tools should facilitate such access. And they may want to look at the information from wide variety of possible views. So it is the same sales information, but that they may look from a multidimensional aspect, because typically the organizations have multiple products and multiple channels and multiple people. And also the thing is that the sales vary over the seasons or the time of the year. So in a way, they need to get the information through the multiple perspectives to better understand what is going on. Now let us look at the CORD's rules for OLAP. As many of you may know, E.F. CORD was the person who has proposed the rules for RDBMS, and those rules have been widely accepted, and all the major vendors create the RDBMS products that conform to the rules proposed by E.F. CORD. Later on, he had proposed some rules which should apply for OLAP products, online analytical processing products. Now let us look at what he has proposed about 20 years back. CORD says that the OLAP tools or the OLAP products should support multidimensional view. That is to say, the decision makers require a multidimensional view of the subject that they are analyzing to understand or to better gain the insights and take the strategic decisions. And the product should provide the transparency. So that is, it should be independent of the underlying the data repository, independent of the database that you are using at the back end and the type of the source data. And such a transparency will make people comfortable to use these products. And the OLAP product should provide a single coherent view to the users, and it should make the information independent of the physical storage that is laying in the background. And the very important aspect of the OLAP is the reporting performance. As you know, when they're looking at the data to be analyzed, a manufacturing organization or a large retail organization may have millions of transactions that happen, and some of the analysis require that the entire data set be considered for the purpose of presenting the information. So if the OLAP tool has not done enough groundwork to present the information, so depending on the size of the data that you are dealing with, there will be significant difference in the performance that you would observe. So for example, a retail chain deals with, let's say, 10,000 products that they sell in their store, but they have 100 stores that are spread over the country for which they are doing the analysis. So now if the OLAP product hasn't done enough groundwork, so what will happen is that whenever the knowledge worker is analyzing the product-wise data, it is going to be much more slower than the when they are analyzing the store-wise data. So it is necessary that the information is prepared and pre-computed if required and stored in such a way that the reporting performance is largely consistent. And it should support the client server architecture that enables you to access the information using any client that you like to use, or it may be a browser based, or it may be a thick client, or it may be a machine with a different operating system. And it should provide for a generic dimensionality. There should not be any restrictions imposed saying that you can only have so many dimensions, etc. Or it should not say that in along single dimension the performance will be very good, but not along the other dimensions. This is like the example that we have taken. So there may be too many products, but there may be lesser number of stores, but the response and the functionality provided across the dimensions should be generic. And the OLAP should provide for dynamic sparse matrix handling. That's important, considering that they may be each dimension may have numerous widely varying cardinality. So that is, you may have 10,000 products, 100 stores and 5 promotions, etc., or 12 periods across which you are analyzing. So it is important that to realize that the matrix of the information may have lot of zeros or insignificant values. So for example, in a retail chain, there may be a product that they keep in the store because it is necessary, but the store may be selling it very rarely. So that information, it may be when you take a count of the products sold and you're creating a multi-dimensional cube or array, so you may get many zeros there. So in such situation, the product, the OLAP, should have the ability to handle the sparse matrix properly, and so that the processing is optimized. And it should provide for multi-user support, so it is possible that there is a need for collaboration among the users. So the OLAP tool should facilitate and should enable the cross-dimensional operations. So that is to say, the dimensions have hierarchy and the dimension should be connected in order to understand better. So that is to say, for example, we may say that they want to know the products they are sold at various regional levels, at the city level, at the state level, at the region level, and again they may want to create a hierarchy of the product, saying that a product category, a product brand, or a product specific model. So, and at the same time they would like to connect these two. For example, in a particular city, a particular model, how is it doing? So it should facilitate such analysis, and it should provide an intuitive interface in order to do the operations, and should provide sufficient level of flexibility for working with the information, and should permit the unlimited dimensions and aggregation levels. A typical analysis session of a knowledge worker would go like this. So a knowledge worker has noticed, as he is looking at some of the reports, that there is a profitability dip in the enterprise for a particular period. So they would like to know, why did it happen? So they would move to a next place and they see that, then what exactly, how are the sales? And they realize that the sales are okay, then they may want to analyze based on various regions, that how is the performance within the profitability across the regions. So now they realize that it is not because of the drop in sales that the profitability has dropped. That can be one possible dimension based on which the sales could drop, but it happened possibly because of some other region the sales are at the same level, but the profitability in a particular region is very low. So what they see is that the Europe has contributed very low profitability compared to possibly previous period. Then they would look at how is it that the Europe is contributing so low profit. Is it based on something in a particular country, or is it big? So they wanted to analyze how is it that with respect to the countries, and the answer that they get is that yes, for some countries it is unchanged, but for some other countries there is a sharp decline. So then they possibly started looking at what are those countries. Yeah, they fit into all those countries fall into one group, which is the European Union. So as you know, all the countries in Europe are not part of the European Union. And then they look into the European Union and they analyze why is it that the profit is low in the European Union. And they realize that the direct costs have not changed, but the indirect costs have increased, because of which, since the sale price is not changed, the profit has reduced. And then they realize that what is the element that is contributing to the indirect costs. So the indirect cost is coming because the tax increased on some of the things. It may be the tax increased on the freight, or on some of the raw materials, or on some other elements. The indirect taxes have increased, because of which the overall cost of production increased, because of which the profitability reduced. So as you can see, to get to this truth, they needed to go through so many elements, and at each point they needed some form, you may call it in a rough terms, a report or the information. So that would tell them what is it that going wrong or right. So in a way, if you look at the steps that the analyst has taken, so the analyst had initially looked at the countrywide monthly sales, and then looked at the monthly sales by the worldwide regions, and then looked at the European sales based on the observation that it is the Europe which is seemed to be causing the problem, and then by the countries, and then the costs within the European countries. So as you can see, each of them is representing a different kind of a query if you're looking at from an SQL perspective. And it is also that each one of them, the one is related to the previous action that they had taken. That is important. So what they had done earlier, so that initially they noticed that in the Europe the profitability has dipped. So immediately they wanted the report only for the European countries at the country level. So thereby they could gain the insight, and they finally zeroed in on the European Union, because it is the countries of the European Union which are causing the dip in the profitability. So what we notice is that the analysis session requires a quickly moving from one form of information to the another form, and typically there is a relation between what you have done at previous step and the next step. And at the same time, considering that they need to go through the multiple steps, the analyst will be frustrated if some of the steps are going to take very long time. So as the analyst had performed the analysis, we may notice that what the analyst had done falls into some of the operations. For example, you may notice that a simple operation like the computation of the profit margin. So how can you get the profit margin? You need to calculate the sales minus costs. And then the analyst was calculating how much of it was a direct cost and how much of it was indirect cost. So that is, he was looking at the part of the cost. And then the analyst was going by the hierarchies. So initially looked at the country level sales, and then combined them to see that which are the regions which have caused the dip. And then they realized that it is the Europe which has caused the dip, and then they went down to look at for only European countries. And so the analysis requires the numerous operations that they need to do, which are not quite like the regular mathematical operations that you do. But here these operations have a different nomenclature that we'll come to see. They are generally referred as a roll up, drill down, then slice, dice, pivot. And finally these operations will help the person to zero in on the information that they're looking at. And as they're doing the operations, they observe something of this kind. So they may see that the sales are happening as per for each of these product as per some particular the summation over a particular period. And then they may realize that they want to see how is it with respect to for year on year, because typically, as we know, the comparison of the performance is based on the previous similar period. So if you want to know whether you're doing well with the sales of this year, you would like to compare with the sales of the last year. That will give you a good indication. And then, as you may see, the visualization would be better if they look at the comparison by pivot or the rotation of the information. So the analyst may have a greater insight and be more comfortable if he or she observes the information in a different perspective compared to the previous perspective. So the OLAP tool should facilitate that. Now let's look at why do we need specialized tools. We had several tools to do the computations, such as what we have seen, for example, the aggregations and further down the aggregations across various dimensions based on various values. But when we are looking at the other tools, first tool that comes to our mind is the spreadsheets. The spreadsheets have been very popular with the business community and particularly with the business analysts. But the spreadsheets are not very helpful when you have got a huge data. That is, let's say a large retail chain may want to analyze 1 billion transactions. So it is way beyond the capability of an Excel spreadsheet. That is point one, or any spreadsheet for that matter. And it becomes very cumbersome. The moment the data is very large, moving across the data is going to be very cumbersome. And then as you enter the multidimensional data, there is a huge level of redundancy when you're storing it, because the Excel or the spreadsheet is dealing with the maximum of a tabular fashion. In fact, it comes as one dimension. And so when we are representing the multi-dimension data into one dimension, we need to put a lot of redundant elements in order to make an equivalent information presentation. So that also we're going to see in a short while later. And then it will also require a lot of effort and a lot of the scripting in order to create the multi-dimensional views. And not everybody is comfortable, and that scripting language may not be the best or most user-friendly language that is available to create the information. And the other tool that is very popular and widely used is a regular relational DBMS, which offer the structured query language. And the SQL was originally meant for end users, but the syntax is still not very easy except for very simple operations such as select or insert. But as you create the compound queries and start creating the group by or the other operations, the syntax is going to become more and more complex, and you need to understand the structure of the information very well to create the syntax. And then the vocabulary is not very suitable or appropriate for the decision makers who deal with this information. And also the SQL is not found suitable for complex calculations, though they are incorporating more and more mathematical functions. But in spite of that, it is either takes a lot of time to write or takes a lot of time to execute. And added to that, as we have seen in the analyst session, a real world session requires the queries to be made one after the other. And each one of the queries may translate into full table scans, and some of these tables can be very huge and may require multiple joins. As you know, the relational databases join is the most costliest operation, and then may require aggregations, grouping, sorting. All of them are costly operations depending on the size of the data that you deal with and the resources that are available. And so in such situations, you cannot guarantee a uniform response time, and the response time may not be reasonable for a continuous session that the analyst would require. As you know, in the previous session, if one of the operations takes half an hour, the analyst would be frustrated and may not be comfortable using that any further. And let's look at the desirable features based on what we had discussed for OLAP. And the OLAP requires that any OLAP tool should support multidimensional analysis. These are what we have seeing at the left are the basic features. So it should provide a consistent performance and should facilitate interactive response queries. That means the response time should be very fast. Should facilitate drill down or roll up. That is, as they have seen that the Europe is the problem, then they would first like to see which part of the Europe is creating the problem. Similarly, they may want to roll up, saying that what is the overall impact that they are seeing from the impact of the parts. And they may want to navigate to the details, or from the details they may want to come back to the summaries. And they may want to select a particular, for example, in the Europe, as they are analyzing, they may want to know that it's the France which has caused the largest dip. So they may want to look at what could have happened there. And then they may want to look at the multiple views, because they may have to look at from a different perspective to get a better appreciation, and should be easily scalable and should have the time intelligence. That is to say that what is a fiscal period, what is the time year to date, etc. And it is also necessary to have the more advanced features, because the analysts are becoming more and more savvy and would like to do far more operations, and then the businesses are becoming more complex. And so hence you need to have the provision for the powerful calculations and many statistical functions, and should enable the cross-dimensional calculations, because what it means is that, for example, a particular product doesn't sell so well in a particular geography but does so well in the others. So they would like for such combinatorial information, and then it should facilitate pre-calculation, otherwise you will not be able to get uniform response, and should facilitate drill through to reach the details, and then should provide for sophisticated presentation, and should facilitate the collaborative decision making. And then, as you can see, it should provide for deriving the values using the very specific or custom formulae, and should have the alert mechanisms. So that is to say that whenever the sales dip, so the analyst should receive an alert so that the analyst will start the analysis session, and should provide the report generation with agent technology so that the reports can be generated at a particular time or can be delivered in a particular mode. And the SQL of the recent times have incorporated the cube operator. So this facilitates to a large extent the creation of the multidimensional cubes, which are essentially the summation across the multiple dimensions that would provide them a analysis opportunity, thereby that is they're creating the summaries across several dimensions, and thereby they are going to they won't have to go to the detailed data. And also, as we have seen, that provides for navigation. Once you have got a complete cube computed. That is, you have both the sales by euro by country and also sales by the region. So that is to say, you know the sales for the Europe, you know the sales for the European region, or the sales for the France or Germany. Then now it is easier for you to find out and move from one sales data to the other sales data as you are doing the navigation. So you are not requiring to do the computation on the fly. So this is facilitated in the SQL. So this is one form of the OLAP that has been incorporated. And the major SQL vendors today provide the cube operations. And the way the cube operation works in most of these vendors is that to do a cube computation, first you need to identify what are the sources of data on which you do the computation, and then you need to build the logical views, because your dimensions or facts may not come from a single table, that is the physical table. So as we may know, there are role-playing dimensions, so that same physical table may be playing the multiple roles. So for that reason, you need to have a separate logical definition to represent the dimensions and the facts, and then you can give the command to build the cubes, and then after that you have all the summaries that are required, and you will be able to carry out the analysis.